Welcome everybody. Today we will be solving some problem from chapter 9 on your textbook. We need to find, like, I'll solve 9.60. We're going to solve problem 9.60 on your textbook. So we need to find the impedance Z input of this circuit. Here the values are 25, this is 15 J, this is negative J 50, 20, 30, J10. So we have to find the input impedance in this circuit. So to find this input impedance, we need to see their configuration. We need to see the impedance configuration of the impedances, like how the impedances are connected. So at first what we can do, we can assume the series combination of these two impedance, like we can consider they are the series combination of this is 25 plus J15, and here we see a series combination of these two impedances. Let me write them. Z2 is 20 minus J50, and for these two impedances we can write Z3 equal to 30 plus J10 ohms. Now if I write the simplified circuit, is look like this. So this is my Z1, this is Z2, and this is Z3. So from this simplified circuit you can clearly find that Z2 and Z3 in parallel, and that is in series with Z1. So your Z input will be Z1 in series with Z2, and Z3 are in parallel. So now I plug in these values here. So 25 plus J15, and then so I also can write down here Z1, this will be Z2 times Z3 divided by Z2 plus Z3. So you can write 20 minus J50 times 30 plus J10 over 20 plus 20 minus J50 plus 30 plus J10. So if you can use calculator to solve this, you will find the total number will be 57.097 plus J of 9878 ohms. Now sometimes we might ask you to find the impedance diagram. diagram, or it's might called impedance triangle. So to find impedance diagram, we can find the impedance diagram for that entire circuit Z1, Zin. The entire circuit impedance is Zin. So you see the entire circuit got 5197, the resistive, and this is the reactive part. So you can write it like the R, total R or R in, and this is X in. So now in real axis you have to show your R in real axis. So this is your R, and this value is 51.097, and you have to find the imaginary value. So I prefer to draw it from the tip of this, and this is the imaginary axis in this way, and this value is 9.878 ohms. So now if I find the resultant of this, that means that the impedance Zin. So this is my Zin, and the angle here will be so you can find this value in the polar form, convert in the polar form, I can find the angle. So if I solve in the polar form, we have 51.09097 plus 9.878 I. So now if I convert to polar, it will be 52.04. So this value will be 52.04, and shift this gives us 10.94. So we can write Zin equal to 52.04, and this is 10.94. So this is how we can find the impedance diagram for the entire circuit. And if you want to find the impedance diagram for this branch, for Z2, you'll see the resistive value is 20 in the real axis. So this is 20 ohms in this way, and the capacitive value is this direction. It will be negative 50 ohms. And then this will be the resultant. So you will get 20 minus 50I, shift this will get us 53. This will be 53.85, and angle is negative 68.2. Angle is negative 68.2 degrees. Similarly for Z3, you can see it will be real axis got 30 and imaginary axis got 10. So I got 30 here and 10 here. And this is the value. So the polar magnitude will be 30 plus 10 I. If you convert to polar, you'll get 31.62, and the angle is 18.43 degree. So just only one thing to mention here, that capacitor will be on the negative imaginary axis, and inductor will be positive imaginary axis, and resistance in the real axis. And if you want to show the total impedance diagram, that means just or impedance diagram for the complete circuit or the whole circuit, then you have to show the impedance of these two in parallel makes how much here, and then that will be in series with this. That is the impedance of the equivalent circuit, impedance for Z3 and impedance for Z2. Let us solve another example, 9.66 on your textbook. So I already have the solution here, so I just wanted to show you how we can solve this example. So for this circuit in figure 9.73, we have to calculate ZT and VAB. ZT is the total impedance looking from the input side, and VAB the voltage over here. So if you look at this circuit here for finding ZT, if you want to look at the circuit here, you will see these two branches 20 and Z5 in series. So I combine them, 20 minus Z5, and this branch also in series 40 and 10. So I make this Z1 and Z2, and this branch is completely parallel with this one. Sometimes students make mistake, they think that 20 in parallel with Z10 and minus 5 is parallel with 40, but that's not true. 20 and Z5 is the whole branch is in parallel with this whole branch. So we need to simplify this branch first, and then we need to simplify find the equivalent impedance for these two parallel branches. So we got Z1 and Z2, then we find the ZT equal to Z1 parallel Z2, so Z1 times Z2, Z1 plus Z2, and if I use calculator, you will get this is in rectangular and this value in the polar form. Now if I want to find the total current IT here, you will get the IT equal to the voltage over the impedance, total impedance, you will get the total current. Now this total current will be distributed in these two branches. You can use current division law, or you can also find, they are parallel, so this same voltage will be appear across this branch and this branch. So you can find this voltage over the Z1 and this voltage over the Z2. You will get the current here and also current here. So here in this slide, I just use current division law. So the total current is this times the opposite branch impedance divided by the impedance of both branches. Sum of the impedance of both branches, you got this. And then I use KCL to get Z2, because the total current is IT. So IT minus IZ1 is equal to IZ2. So I show you this method, like how you can do it using this way, or just or you can find I1. As you see here, this voltage is same, so you can write I1, the current in this branch will be 60 90, the voltage over 20 minus J5. Don't divide with only 20, because the entire branch is 20 and 5, and the entire branch is in parallel with this the voltage source. So I got this. So if I use calculator, we can find the value here. So you see, we can operate both in mixed mode, like this value in polar and this value in rectangular. So the calculator can carry both of them together. 60 angle here 90 divided by 20 minus 5i. So you got negative 705, and the value of I is 2.823. If you want to find the polar form of this, so it will be 2.91, and angle is 104.03. Be careful, by default your calculator will show the rectangular form. Then I2 will be 60 angle 90 over 40 plus J10. So I solve it. I got 60 angle 90 divided by 40 plus 10i. So it goes to 0.353, and the imaginary part is 1.4117. If you want to get the polar form, so that will be 1.455, and the angle is 75.96. Now to find VAB is basically VA minus VB. So how to find VA? So VA is the voltage from this point to this point. So if you assume that this point is grounded, then VA will be from ground to this point. So you can write VA will be I1 times J5, and VB will be I2 times 40. So I1 is, if you want to write the polar form, 2.91 on 0403. You can take the rectangular form too, times negative J5, and I2 is 455, 75.96 times 40. So I already have this on my calculator. I made it 40, multiply with this 40, then I multiply with negative answer, plus this one 2.91 shift angle is 104.03 times negative 5i. So you got the value will be negative 1.689 times 10 to the power negative 3, and J is minus 52.94. If you go to the polar form, so it will be 52.94, shift angle is minus 90 degrees. On the slide I showed the how to find VAB on the other method using I use different method. So on the slide I use different method for finding VAB. This method tells us, just you see here, VAB will be the voltage in this loop. So if we start from 40, so you'll see the positive sign will be here, negative sign here, and for 75, negative here, positive here, and the drop in this will be I2 times 40, and end sign is negative, so it's a negative. Okay, so sorry, I took the other side. So if you see the other side, this side will be positive, negative, and this side will be positive, negative. So if you see here VAB, if I go from this one, this side, you will get this way. So the beginning side is 20 times I1, and here beginning sign is negative 10J minus I2. So you can write negative 20 I1 and positive I2 40, I2 Z10, I2 times Z10, and equal to negative VAB equal to 0. So negative VAB equal to 0. So you can write VAB equal to negative 20 I1 plus Z10 I2. Or you can go in this way, in this loop. So from this loop, if you start from this point, you see we have 40 I2, and here we have negative J5 I1 and plus VAB equal to 0. So you can find this, use the find the expression VAB will be negative 40 I2 plus negative 5 I1. So plug in the value for I2 and I1, you will get VAB. So thank you. If you have any question, please comment under the if you have any question, write your question on the comment box. I'll be happy to answer your question.